Hi, everybody. So today we are working on one-to-one functions and inverse functions. And let's go ahead and get started. So if we're given a set of points and I have these 5 points, I know that this is a function because the x-coordinates do not repeat, and that's review. But now we have a new vocabulary word, one-to-one. A one-to-one function is a function whose x-coordinates don't repeat, but one-to-one means the y-coordinates don't repeat either. So you can have a mapping also. So we've got our x-coordinates, can be basically just anything, and then I have my f of x over here. Notice that for every x, it is assigned one and only one f of x. So we know that these x don't repeat, so it's a function. The y's don't repeat, so it's also one-to-one. In this example, with the animals and the life expectancy, notice that we've got the dog has 11 years life expectancy, and the cat also has 11. So that 11 is going to repeat, once for the dog and once for the cat. And if you look at it at ordered pairs, you can see that these y coordinates are repeating. So this is a function, but it is not one-to-one. Now let's look at graphs. So we know that we get a function when we use the vertical line test, if that vertical line touches the curve in only one place. So this green graph is a function. The blue graph is a function. The pink graph is not a function. You can see how it's hitting in two places. So let's do a one-to-one test. We use the horizontal line for that. So if my horizontal line touches in only one place, it really does touch in one place there, this green graph is one-to-one. Notice though that the blue graph, that parabola, is not one-to-one. And the pink graph is, yes, one-to-one. That horizontal line is only touching in one place. If you have a function that is strictly increasing or strictly decreasing, like this green graph that's strictly increasing, it's going to be a one-to-one function. So some questions. Use the horizontal line test. So these came off of MyLabs Plus. Yes, this is a function and it is one-to-one. Down here, horizontal line test fails. This is not one-to-one. And looking at points, look at the y coordinates, a 9, 6, 14, and -8. The y's do not repeat, so yes, this is one-to-one. Okay, moving on to inverses. We're going to look at two sets of points and look at the inverse relationship. We're going to look at two graphs, and then we're going to look at two equations and inspect these inverse relationships. So I have this function with 5 points in it. I know the domain comes from the x coordinates, and I know the range comes from the y coordinates. The inverse of this function, if you'll notice, what happens with the x and the y? I'm just reversing them, okay? I'm exchanging them. The 3 and the 3, 0, 0, the 2 here goes here, the -4, and so on. So to find an inverse of a set of points, you just switch the x and the y. But when you do that, notice that the domain of the original function becomes the range of the inverse. And the range of the original becomes the domain of the inverse. And of course, you can use mapping. You can find an inverse just by switching. The f of x becomes the x, and the x becomes the f of x. And a MyLabs Plus question, find the inverse. So I'm just going to switch the x and the y, switch the x and the y, and so on. My domain now of the inverse is -14, 0, 15, 2, and 8, and -3. The range 4, 5, 6, 7, and 8. Graphing inverses. So since we are switching the x and the y in the ordered pairs, we're going to do the same thing with the graph. So if my original has the point AB, my inverse has the point BA. Notice how I write the original function as f, and the inverse is f to the negative 1. Over here, my original is red, and the inverse is blue. Now, graphically, the original function and the inverse are symmetric about the line y equals x. Okay? The red original and the blue inverse are symmetric with respect to y equals x. So you can just see here's the red, that's a cool little x cubed function. Its inverse is the cube root of x in blue. You can see how they are symmetric about that line y equals x. Okay, another original function and its inverse, and see how the graphs. If I fold this along this dotted line, the red picture would overlap perfectly with the blue picture. Same thing here, -4, -1 is on the original, so -1, -4 is on the inverse, and so on, just switching the domain and the range. So some questions. If the domain of a one-to-one function is 6, infinity, then the range of the inverse has to be 6. Okay, remember, this would switch. The x becomes the y becomes the x. If a one-to-one function, we have f of 6 equals 8, then the inverse would be f of 8 equals 6. The function and its inverse are symmetric with respect to the y equals x line. If f and g are inverses, the domain of f is the same as the range of g, and that is true. Now let's look at equations. I've got my function f and my inverse function, and I want to look at their relationships. Now, if I compose those two functions, if I put f of x inside, composed into f inverse, my answer will come out to be x, and vice versa. When you compose a function and its inverse, you will always get x. Okay, so let's verify. I have g of x is x cubed, and the inverse of g is the cube root of x. I'm going to start out taking g and plugging it into the inverse. So I'll take the x cubed and plug it in right here and get the cube root of x cubed. Remember, when you compose, that x goes out and the whole new function goes in. The cube root and the power of 3 cancel out, and you get x. If I go backwards and I put the inverse into g, I'll take the cube root of x and plug it into the x, and I have my cube root and my power of 3 cancel out. Okay, another one. I have two functions here. I'm going to plug the f into the inverse right here. That x goes out and the 2x plus 3 goes in. The positive 3 and the negative 3 cancel out. The 1/2 times 2x cancels out, and it leaves the x. And I can go backwards. I can take the inverse and plug it into this x. If I do that down here, I'll have the 2, then the inverse, and then the plus 3. Distribute the 2, and you're going to have the 2 and the 1/2 cancel out. The negative 3 and the positive 3 cancel out. So the composition of two inverses is x. Now, how to find an inverse? You switch the x and the y, and you solve for y. So I have my original. F of x is the same thing as y, so I like to write it like this. So this y becomes x, this x becomes y, and then I just solve for y. I'll subtract 3, divide by 2, and that is my inverse. Sometimes you can write it like this if you'd like. And if you graphed them, you could see that they're symmetric about y equals x. Okay, here's a complicated one. I'm going to make the f of x the y, and then I'm going to switch it. So the y becomes the x change over to y. I'm going to get rid of my denominator always. So what I'm going to have on the right side, that will cancel out, and I have 2y plus 1, and I have this x times y minus 1. Distribute this x. Then we're going to do a little move it, keep it. Any term with a y goes on the left. So this term is going to stay. This term is going to move over to the right. This term will move over to the left, and this term will stay on the right. Once you get your y's on the left side, factor out the y, okay? Then you just divide by what's left, the x minus 2. And this is now your inverse. We'll try one more. If this is my original, f of x changes over to y, that means the same thing. And now I'm ready to go. Y switches to x, and the x will switch to y. And I'm going to do some math. I'm going to multiply both sides by y minus 3, and then the y minus 3 on bottom will cancel out. I will distribute this x, and I have xy minus 3x on this side. Now, any term that has a y must be on the left side. This term stays. This term moves to the right. This term moves to the left. Factor out your y. You're left with x minus 4, and you divide that away, and there's your inverse function. If you'll notice on this example, the domain is x cannot equal 3, and the range is y cannot equal 4, because we know the vertical asymptote and the horizontal asymptote. So on the inverse, if you'll notice, the domain of the original is the range of the inverse. The range of the original is the domain of the inverse. And we just use x for domain and y for range. And that's really all there is. So good luck. And if you have any questions, please just let me know.